Today we're going to start talking about the unit circle, and we need to go back to a topic that you studied in geometry, which are your special right triangles. The triangles that had angles of 45 and 45 and 90 degrees, also known as an isosceles right triangle, and your 30, 60, 90 triangle there, or 30, 60 right triangle, um, as you see in the pictures. And what we learned on those particular triangles is that in a 45-45 right triangle, what happened was that our side lengths were the same length. And then our hypotenuse was radical 2 times that length. And so in geometry, you probably learned it as x radical 2, but I'm going to look at the coefficients instead of 1, 1, and radical 2. In terms of the 30-60 right triangle, across from the 30-degree angle, we're going to have length 1. Across from the hypotenuse, we're going to have length 2. And across from the 60-degree angle, we're going to have radical 3. Those were some ratios that you learned about in geometry, but it may have been a few years since you have seen these or thought about these ideas. But what we want to do is we want to take this idea here and we want to apply it to the same triangles. It says use special right triangles to fill in these lengths of these missing sides. We don't want to write any decimals here. But first of all, what we've got is we've got a 30-degree angle. So we're going to refer back to our triangle, which we wrote the answers in green to. And what we see in the triangle here with the green numbers is that our hypotenuse has a value of 2. Well, now in this particular triangle, our hypotenuse is 1. We took our hypotenuse and we cut it in half. And what that means then is that the angle across from the side length across from the 30-degree angle, which originally was 1, is now going to have to be cut in half. And our other side of our triangle there had a length of radical 3, but since we had to cut our hypotenuse in half and we cut our side in half, we also have to cut our radical 3 in half. And I'm going to skip over that middle triangle for a second and do the same thing. Because this one now, we're looking at the triangle, the same triangle with the green, but we're looking at it with respect to the 60-degree angle. But in our original triangle, our hypotenuse is 2. And now our hypotenuse is 1. So we're going to do the same thing here. We're going to have to divide our hypotenuse by 2 to get that value of 1. When we divide that hypotenuse by 2, then what happens is that across from the 60-degree angle, we're going to have to take our radical 3 and divide it by 2. And we're going to have to take our other side length, which was 1, and divide it by 2. Now it's the same triangle, so clearly those values aren't going to change. So our other triangle, the 45-45 right triangle, has 1, 1, radical 2. So what has to happen here is that originally our hypotenuse was radical 2. Well, now what we're going to do is we're going to take radical 2 and we're going to divide it by radical 2 to get 1. So, in terms of our other lengths, what has to happen is we need to take our other length of 1 and divide it by radical 2. And because it's an isosceles triangle, that means that this length is also 1 divided by radical 2. Well, typically in math, we are not supposed to have a radical in the denominator. So what we do is something called rationalizing. You may have forgotten it from Algebra 2. But what it means is we need to get the radical out of the denominator. So in order to do that, what has to happen is we multiply this fraction by radical 2 over radical 2. And what happens is when we multiply, remember when we multiply fractions, we multiply the tops together and we multiply the bottoms together. So 1 times radical 2 is radical 2. Radical 2 times radical 2 is radical 4. Well, we can't simplify, I don't know why I changed colors here, we can't simplify radical 2. But we can take the square root of 4, and it is 2. And what that means here is that 1 over radical 2 has the same value as radical 2 over 2. And now that we've seen these triangles here, and I'm going to separate this out a little bit, I just wanted to have space so you could see what I did. But those triangles up here are important for our next little segment here. And in order to do this, we need to think back again to geometry about what your geometry may have called SOHCAHTOA. And those are the ratios for sine. Sine S equals the opposite divided by hypotenuse. Cosine C equals the adjacent divided by the hypotenuse. T, tangent, equals the opposite over adjacent. So when we look above on our paper, and I'll have to flip back, but when we look above here, we want to figure out what the sine of 35 is, and the sine of 45, and the sine of 60 is. But as we look at our first triangle, sine is opposite divided by the hypotenuse. Across from the 30 is the opposite. Across from the right angle is the hypotenuse. So what we end up with on this first value is we end up with 1/2 divided by 1. Well, 1/2 divided by 1 is just 1/2. If we look in our middle triangle here, the sine of 45, wrong thing, but sine of 45. Here's our opposite. Here's our hypotenuse. Across from the 45 is radical 2 over 2 divided by 1. Radical 2 over 2 divided by 1. If we simplify that, we end up with radical 2 over 2. Sine of 60, we do the same kind of thing. We look back at our triangle. Across from the 60, there's the opposite. Here's our hypotenuse with 1. We get radical 3 over 2 divided by 1, which is radical 3 over 2. And then we can do the same thing for cosine. And cosine is the adjacent divided by the hypotenuse. So when we look at here, we've got opposite, we've got hypotenuse. This must be the adjacent. So the adjacent is going to be radical 3 over 2 divided by 1. Which is radical 3 over 2. And if you're really paying attention here, what you may notice is that sine has the hypotenuse for the denominator, and cosine has the hypotenuse for the denominator, and on all 6 of these values, which are sine and cosine, our hypotenuse has a value of 1. So when we go to the cosine of 45, it's going to be radical 2 over 2 divided by 1. Which is radical 2 over 2. And cosine of 60 is going to be 1/2 divided by 1. And of course we simplified all of those. So now let's take a look at one of these triangles, and we're going to put it on the coordinate plane. We're putting it on a grid. The first question says, what would the x and the y coordinates of point A formed by the 30-degree angle be? So what we want to do is we want to fill in the other 2 sides of this triangle, and we can flip back here to our 30-degree triangle, and what we see is that this side of the triangle is radical 3 over 2. And this side of the triangle is 1/2. And what happens is, if we start at the origin and we measure here, because we want to know what's the value of point A, we're going to go over radical 3 over 2, and then we're going to go up 1/2. Our base of that triangle is radical 3 over 2. Our height of that triangle is 1/2, but we went radical 3 over 2, 1/2, which I'm going to write down here so we can read it a little bit better. Radical 3 over 2 and 1/2 is the value of point A. Well, if we do the same thing for the 45 and the 60 degree angle, the triangle that we just did was already, we just did that one. It's in dotted line. And now what we've got is we've got the 45 degree triangle. And remember, here's 1 for our hypotenuse, and then this is radical 2 over 2. And this is radical 2 over 2, which means that point B is radical 2 over 2, radical 2 over 2. And if we look at the 60 degree angle, so now we've got a dotted 30 degree triangle, we've got our dotted 45 degree triangle, and then we've got our 60 degree triangle. What happens is we would go over 1/2 a space, we would go up radical 3 over 2, hard to put in here, but we get 1/2 and radical 3 over 2. The thing that we need to recognize here is, what is the radius of the circle? Well, the radius of the circle is our hypotenuse. In all of these triangles here, it's 1. And if you look at the 3 points we've traced out so far, they all lie on the circle centered at the origin. So what we just came up with here, and it's hard to fit it in on this file here, but we have radical 3 over 2 and 1/2 at this point. And then we have radical 2 over 2, radical 2 over 2 at this point. And we have 1/2 radical 3 over 2 at that point. I know it's squeezed in a little bit, but do the best that you can. It's a little bit easier to write on paper than it is to write on the board. So as we flip our page over, that's not actually what you see. This is really at the bottom of the 3rd page of your notes. What we're going to do is we're going to take a couple minutes and we're going to cut out these triangles. You don't have to cut right along the triangular lines. I just cut a rectangle with this triangle in it, and a rectangle with the 45 degree triangle in it, and a rectangle with the 60 degree triangle in it. And we're going to use those in a moment. I can also recommend that you turn over those triangles and trace them on back with the angle and the lengths, because we're going to write the lengths out to the sides for each of these, including the hypotenuse, remember, which is 1 on each of our triangles. So I turned off the video for a little while to circulate around the class and help people work with their triangles in this circle. And so by now you should have the circle filled in. And what we haven't done yet is we haven't talked about the degrees from the circle. We have all of the values of the ordered pairs in the circle, but we really don't have the degrees in here. So that's going to be the next part that we fill in. And if you didn't get all of the circle filled in when we were working in class, then now's a good time to finish. But remember, with our red triangle here, this was the 30 degrees. And then we did 45 degrees. And over here with the blue triangle is the 60 degrees. And in fact, where I should have started is 0 degrees. Well, we have 0, we have 30, we have 45, we have 60, we have 90. And then what happens is that we go into the second quadrant here, and we can figure out the values. And what happens is, if we add 30 degrees to 90, we get 120. And if we add 45 degrees here, because that was a 45 degree triangle here, then what happens is we get 135 degrees. And then we can take our reference angle here. Remember, this was 30, so our reference angle is 150. And I think I said that wrong, really, on the 120, because our 120 here, let's see if I still have the triangle in here. If we take this blue triangle and we put that back in over here, trying to put this back in. Oh. So there's that triangle. What happens is this angle right here, connecting back to the x-axis, is 60 degrees. So when we're measuring this, and I'm going to erase this, but we're measuring this, it's going to go from here to here. So we've got 60, and if we make a full protractor, that would be 180 minus 60, which is 120. I don't want to jumble up the circle more than it's circled, or more than it is already. So we have 90, 120, 135, 150. Here we've gone half of a rotation, 180 degrees. And then as we continue here, this is going to be 210. And this will be 225. And our next value is 240. And not 3, but 270 degrees. Then we get to 300 and 315 degrees, 330 degrees. And remember, when we go full circle, we get 360 degrees. There's the unit circle. And try to fix my writing a little bit here. But you will be responsible for learning this. There are some good unit circles on the internet that you might want to look at to help you to memorize this as well, although I hope that the reflections that we've been working with helped you. But as we finish our notes here, it says use the work you did with triangles on the front page to fill in the following table. And what we've got is we've got our angle measure, so we can look back here for our 30 degrees. Looking back at our unit circle, the 30 degrees, what we get is we get this ordered pair of radical 3 over 2 and 1/2. And if we look on the front page of our notes, I'm not going to flip back on the screen completely here to the front page, but the value of sine of 30, that was one of the first things that we did in these notes, ended up to be 1/2. And the value of cosine of 30 degrees was radical 3 over 2. When we dealt with the 45, well, our ordered pair on the circle for 45 was radical 2 over 2 and radical 2 over 2. And when we look at the front page of our notes, radical 2 over 2 is the value of sine, and radical 2 over 2 happened to also be the value of cosine. And then with our 60 degree, our ordered pair on our unit circle is 1/2 radical 3 over 2. So we've got 1/2 and radical 3 over 2. If we look back at the front page of our paper, what we find is that the sine of 60 ended up to be radical 3 over 2. And the cosine of 60 is 1/2. And so as we look at that, can we make any generalizations? What relationship do we notice between the coordinate on the unit circle and the values of sine and cosine? Well, if you look closely here, the sine values, it looks like the sine values is a y-coordinate. And the cosine value seems to be an x-coordinate. So look at the point shown below. And we already have kind of looked at this before. It says, look at the point shown below, which corresponds to 90 degrees. You need to read the whole sentence there. But as we look at that, what are the coordinates of this point? Well, 90 degrees is here, even though my board is disoriented. Let's see if I can get that close there. 90 degrees is here. The coordinates of that point, we went over 0, and we went up 1, because that's the radii of the circle. So 0, 1, the coordinates of the point. So the question then is, well, what is the value of sine of 90? Well, we just said that sine is a y-coordinate, so sine of 90 equals 1. We also said that cosine is an x-coordinate, so cosine of 90 is 0. It says, what would be the coordinates of the point that corresponds to 0? Well, if we flip over to 0, here's 0. That means that we went to the right 1 space and we went up none. So the point that corresponds to 0 is 1, 0. And so what is the sine of 0? It is 0, the y value of that coordinate. And what is the cosine of 0? It is 1. As we finish, use the unit circle you just made. Your answers should be exact, no decimals. So we go back to this now. Sine of 120. I have to flip back and forth, but I'll just do this a couple times. We go back to the unit circle. Sine of 120. Well, we find 120 here. And the sine of 120 is going to be the y value of this blue point here, and that is going to be radical 3 over 2. If we go back to our unit circle, the cosine of 180 on our unit circle. The cosine, here's 180, is going to be the x value, so the cosine of 180 degrees is -1. Now, I'm going to fill in the rest of them. Stop the video if you want to do them on your own. You do have a few practice problems on the back of this paper for you to practice as well. But stop the video if you want to try these on your own before you get the answers.